Okay, we are going to continue chapter number 3, transport layer from the from the we are going to continue chapter number 3, transport layer from the computer networking, a top down approach. So let me remind to you that in last class we had discussed TCP reliable data transfer, okay, and we then discussed RTT estimation, at how TCP estimate round trip time, and based on estimated round trip time the TCP sets the time out for the next packet. We also discussed TCP flow control, and we also visited that which field of the TCP segment structure is used for the TCP flow control. Okay. In today's class, we are going to discuss TCP. We are going to discuss TCP connection management, and we will revisit the TCP segment structure. That is, we will discuss some more fields of the TCP header, and then we will discuss TCP congestion. So by discussing the TCP congestion, this chapter will be completed. Okay. So let's discuss the TCP connection management. As you know that in the TCP, the sender and receiver, before exchanging data, the sender and receiver handshake. The sender and receiver establish connection. So in the TCP, before exchanging data, sender and receiver, they establish connection. They do handshaking. What does it mean? That they agree to establish connection, each knowing the other willing to establish connection. By establishing connection means that both sender and receiver, they are willing to establish, they are willing to accept the data from each other. Okay, so this is the purpose of establishing connection. The purpose of establishing connection means that both are willing to accept the data from each other. Moreover, during the connection establishment procedure, this both sender and receiver, they agree on connection parameters. For example, they agree that what will be the sequence number from client to server, and what will be the initial sequence number from server to client. So these are parameters, they are specified in the connection establishment procedure. Okay, that is this, that what kind of what will be the initial sequence number from client to server, and what will be the initial sequence number from server to client. Similarly, they, during the connection establishment, they specify the receiver buffer size both at server and client, and they exchange with each other that the what is the free space, or how much free space is available with the client, and how much free space is available at the server. So these things, they are specified during the connection establishment process. Okay, and how more specifically, how, suppose this is the client and this is the server. So this server, it will be running on a particular IP addresses, on a particular port number. What does it mean? That this server is listening on a particular IP address and port number. It will be open, it is running, it is listening. Okay, so how it start listening? So by using the socket accept method, okay, this server, it goes in listening mode. Now it is waiting to accept connection. Okay, So suppose this client it wants to establish connection, so it will call socket method, and this host name it will be the IP address of server, and port number it will be the port number of server. So when this method is called by the client method, so this method is start connection request. So it's send the connection request. When the connection request is arrived at the server, so the server is already listening, so it will respond. Okay, so these methods are used to initiate and establish connection between client and server. Okay, so connection management, what is it? It is before exchanging data, sender and receiver handshake to establish connection. So connection established means that both sender and receiver agree to establish connection, that is both agree that they are willing to accept connect data from each other. And second, during the connection process, they both sender and receiver agree on connection parameters. Connection parameter can be like initial sequence number from client to server and initial sequence number from server to client. Similarly, the receive buffer space, the receiver buffer at size at both server and client. Okay. So now we are discussing that how the TCP it use three-way handshake. Okay, so we are now discussing in more detail that how connection is established. Okay, so we discussed that when the client wants to establish connection, so it sends this method. So now this method is called. So when this method is called and this method is already running, so what kind of messages are exchanged between the client and server to establish connection and to let to know each other about these things. Okay, so let's discuss this in more detail. Okay, so suppose that this is the client and this is the server. Okay, so suppose the server is already listening on a particular IP address and port number, and this client it wants to initiate to establish connection. So the connection is initiated by client side. Okay, so how it works? So the TCP in TCP the client it will first choose initial sequence number, and this initial sequence number it should be chosen randomly. In the next slide we will discuss if this initial sequence number it is not chosen randomly, then what problem occurs, what kind of problem occurs. Okay, so we will discuss. So when the client wants to initiate connection, so first the client has to choose initial sequence number. This initial sequence number, suppose the client choose X, so this initial sequence number is from the client side. So the client sends the data, so its initial sequence number will start from X. Okay, and second is that the client it will sends a TCP packet, and this TCP packet it is called send message. Why it is called send message? Because in the TCP header this S flag is on. This is called synchronous. This flag will be on, it will be set to 1. Okay, so when in the TCP packet when this S flag is on, so it means that it is the connection establishment connection request. This is the connection request. What does it mean? This S flag means that this client wants to establish connection. This client is requesting for connection. Okay, so in the TCP send message, this is the structure. It will, the sequence number X it will be put here, and the S flag will be on. This is called send flag. This is called synchronous flag. So the send bit it is equal to 1. The send flag is equal to 1. This will be set to 1. It will be on, and the sequence number is put X because this is the initial sequence number. So the first packet it will have the sequence number X. Okay, so this segment, this TCP packet, it doesn't contain any kind of data, it only contains the TCP header. So in the TCP message in which S flag is on, so it means it is the connection request message. Okay, so this send bit on and sequence number X, this message is sent from the client to server. Okay, so when this message is, and you can note that in this message the receive window is also specified. Okay, so when this message is arrived at the server, okay, so the server is already listening, so server accept this message. And now if the server is also willing to establish connection, okay, so the server has to do two things. If this server is also willing to establish the connection, so this server has to do two things. The first thing is that this server will choose its initial sequence number, and this server also choose this initial sequence number randomly. It also choose randomly. Okay, so you can see that suppose this server it choose initial sequence number Y. So this Y, this sequence number, it will be used for the data from the server to client, and this sequence number X, it will be used for the data from client to the server, because in the TCP both client and server they send data to each other. Both client and server they send data to each other, and it is full duplex, both can send any time. So both is sending data, so the client will use its own sequence number for its data, and the server is using its own sequence number for its data. So this is the first thing. The second thing is that the TCP, the server, it will make a TCP segment, it will prepare a TCP segment. The its initial sequence number Y, it will be put here as a sequence number. You can see that this message has the sequence number Y, so it will be put here. And since this server is also willing to establish connection, so it will set S flag. S flag means that the server is also willing to establish connection. So the server is also requesting to establish connection. So this flag is on. And third, that this server has to acknowledge the previous packet. So the previous packet, this packet is received from the client, so its acknowledgement should be sent. So what should be its acknowledgement? So the egg flag will be on, so it means that acknowledge. This is the acknowledgement packet, the acknowledgement is also present in this packet. So it is using piggyback approach. Both send the request, the connection request message, and the acknowledgement, they are combined in the single TCP message. Okay, so A flag will be on, so it means that there is acknowledgement present, and the acknowledgement number will be put here. So what should be the acknowledgement number for this? So in the TCP, the acknowledgement number is for the expecting sequence number. So this message was with the sequence number X, so it means that X message is received. So next the server is looking for X plus 1, so the X plus 1 will become the acknowledgement number. So this X plus 1, it will be put in the acknowledgement field here. So now the receiver, the server, it is send an acknowledgement both in single TCP message, and again there is no data, it only contains the TCP header. Okay, so now the TCP is send an acknowledgement both in the TCP message. So this is called send acknowledgement packet. Send acknowledgement packet. Why? Because it contains both send message and acknowledgement. Send message means that this server is also willing to establish connection, and this is its initial sequence number Y. And the server is acknowledging the previous packet. Okay, that the client, from the client, the previous message is received correctly. So its acknowledgement is sent. So this message is called send plus acknowledgement, and this message, it was only send message. Okay. Now the server, it receives, suppose the client, it receives this message. When this message is received, so first it contains acknowledgement. So it acknowledgement means that the client comes to know that this send message it is received by the server correctly. So this acknowledgement means this one. Okay, so acknowledgement x plus 1 means that the acknowledgement packet is that the send packet is received correctly, and this send message means that the server is also willing to establish connection. Okay, so now the server indicates server is live, and this, so by receiving the acknowledgement it means that the server is live. And now and sending the send acknowledgement, so it means that the server is also willing for connection. Okay, so now this client has to send the acknowledgement for this packet that okay, I have also received this message. So for this message it will only send acknowledgement, okay, because the connection request message already sent from the client. So what should be the acknowledgement number for this packet? Since this packet contains the sequence number y and it contains no data, there is no data, so it's so up to sequence number y data is received, message is sequence number is received. So the next expecting sequence number is y plus 1. So y plus 1 will become the acknowledgement number. Y plus 1 will become the acknowledgement number, and a flag will be on, a acknowledgement bit will be on, it will be set to 1. Why? Because this header it contains the acknowledgement, so only this message will be sent. So this message contains acknowledgement. And what should be the okay, so this acknowledgement is sent when this acknowledgement is received by the server. So server comes to know that now the connection is established. So you can see the first message is sent from the client to server. This is called send message, and then server sends send plus acknowledgement in the single message. This is called send plus acknowledgement message, and then the client sends the acknowledgement. So now by this three-way handshaking, the TCP connection is established between server and client. Okay, now we are going to discuss that why the client it choose randomly the initial sequence number and server. So let me explain it through an example. Okay, suppose that this is the client and this is the server. Suppose server is listening. So suppose the client it sends the connection request message and it choose initial sequence number 0. Suppose it is not chosen randomly, it always the sequence number start from 0. Suppose this message is sent. Okay, now when this message is sent, it is on the way that the client close this connection. Okay, and then client after closing the connection, then the client again start the connection, and the client with the same port number and IP address it is sending this to the server of the same IP address and port number. The IP address and port number used by the client in this connection and the IP address and port number used by the server in this connection, they are these IP address and port number of client and server, they are same in this connection as well as in this connection. Suppose, okay, and initial sequence number 0 is chosen. Okay, again initial sequence number is chosen 0. Why? Because it is not randomly chosen, and again it sends the send message. And suppose this send message is lost. This send message is lost. The second send message is lost. That is the send message, the connection request message of the second connection, it is lost. Okay, and the first one is received. When the first one is received, its acknowledgement is coming. Its acknowledgement is received. So its acknowledgement number it contains 0 plus 1. So this means that this is the acknowledgement for this packet. The client it will assume that this send acknowledgement, this acknowledgement and send message, it is this send and acknowledgement packet it contains acknowledgement number 0 plus 1, and the client assume that this acknowledgement is for this message, although this acknowledgement is not for this message. This message send message it is lost, and this acknowledgement is for the previous for the first send message. Okay, and this is wrong. This is wrong because that connection was closed. Okay, so to avoid this problem, okay, the server and client, they choose initial sequence number randomly. Okay, if it is chosen randomly, then this problem will not happen. Why? For example, the client it choose suppose that the client it choose initial sequence number, for example 5, if it is chosen randomly and it is sent. Okay, and then the connection is closed, and then it establish a new connection. Okay, and it choose randomly, so it will be suppose randomly, suppose it is chosen as 10 randomly. Okay, so and if this sequence number is lost, and for the first the client acknowledgement is received, and the acknowledgement for the first, because the sequence number was 5, so the acknowledgement will be 6. So when this acknowledgement 6 is received, so the client can comes to know that this acknowledgement is for the first message, it is not for this one, so it will be ignored. Okay, so that's why the server and client, when they establish connection, so they choose this initial sequence number randomly. Okay, to avoid this problem, okay. So this is the FSM for the connection establishment procedure. Okay, and it is easy. I think you can follow it. Now, when the connection is established, okay, so the server and the clients, then they exchange data with each other. Okay, both server and client, because the TCP connection it is full duplex. By full duplex means that the client and server, they can send data to each other anytime. Okay, so suppose this data exchange is finished, and now either client or server it wants to close connection. So how it is closed? So the connection it is always initiated. You can see that the connection is always initiated by client. Okay, so the connection establishment it is always initiated by the client, but the connection closure or the connection close, it can be initiated by a client or server. So client or server each close their side of connection. Okay, so when the data from the client side is finished, then the client will close its connection. When the data from the server side is finished, then the server will establish the connection. So if the client data is finished first, then the client will first close its own connection. And if the data is finished from the server first, then the server will first finish its connection. And how the connection is closed? Basically, if client wants to close connection, then the client will send TCP segment with finish bit, with the finish flake, it will be set to 1. So if in the TCP message, if the F flag is set, fin bit is equal to 1, the finish bit it is called F flag, it is also called fin bit, it is also called finish bit. So if the finish bit or the finish flag it is set to 1, so it means that this client wants to close the connection. Okay, so the F, as we discussed, that the S flag or the send flag, it indicates the connection request. So similarly, the fin flag it indicates the connection close message. Okay, so when the client or server it receives the fin flag, okay, so the client or server has to respond with the acknowledgement. Okay, so maybe the fin and acknowledgement can be combined. So let's discuss it through an example. I think it will be much clear to you. Okay, suppose that the client and server they had established connection and they were exchanging data to each other. Okay, so both client and server they were sending data to each other. Okay, And now suppose that the client, from the client side, the data is finished. The client doesn't want to send any more data, can no longer send. Okay, so it doesn't want to send any. So how the connection is closed? Basically the client will call this method, client socket dot close. Okay, socket dot close method it is called. Then the client, it means that the client wants to send to close the connection. So when this method is called, then this method it sends this message. This will be the TCP message. It is called, and its fin bit will be on. Fin bit will be on. Okay, so you can see that that basically when this client wants to close the connection, so it will call this method. And when this method is called, so basically the client, it will send this message. It will have a sequence number, and F flag, the fin flag, it is also called fin bit, it is also called fin flag, it is also called F flag, it is also called finish flag. Okay, so this flag will be on. So it means that if this is sent, then it means that the client wants to close connection. Okay, but the client wants to close connection. What does it mean? That it can no longer send data, but it can receive the data. It can receive the data from the server side. Okay, so this message, it is called fin message. It will be sent. When this message is received, okay, so the server has to send the acknowledgement. So what should be its acknowledgement? Its sequence number is X, so its acknowledgement will be X plus 1, and A flag will be on. So this will be the frame structure, the segment structure. Okay, and suppose the server wants to send the data, so server only sends the acknowledgement for this packet. The server doesn't want to close connection. Why? Because the server wants to send the data still. Okay, so it will, so the server is only sending the acknowledgement bit. Okay, when this is received, so it means that the connection is closed from the client side. That is, the client can no longer send data. However, it can receive the data from the server. Okay, so suppose the server is sending data during this time, and when the server data is also finished, okay, so server also wants to close the connection. Okay, so then the server will send the packet, fin packet. That is, the server will send a message, the TCP message, and F flag will be on. Fin bit, it will be set to 1. F or fin bit will be set to 1. It will be on. Okay, and its sequence number, so it is sent. When it is received, so it means that the client has already closed connection, and now the server has also closed the connection. So it means that neither the server nor the client, they want to send data. Okay, so now the client, but the client has to send the acknowledgement. So what should be its acknowledgement? The sequence number is Y, so its acknowledgement will be Y plus 1. So it is sending the acknowledgement, and now it will wait for 2 multiplied by maximum segment lifetime. Okay, so it is waiting for this time, and then its connection will be closed. Okay, okay, so why? Because maybe that this acknowledgement is not received. If this acknowledgement is not received, then the server will again send the fin packet. Okay, so that's why it is waiting for 2 multiply maximum lifetime. If within this time this packet is not received again, then it will assume that the acknowledgement is received by the server. So it will close the connection, and similarly when the server receives this message, so the server close the connection. Okay, so you can see that normally the client, the connection close procedure, it involves first fin message from the client, then acknowledgement from the server, then fin packet from the server, and then acknowledgement from the client. So this is 4-way handshaking. Okay, but you can note that if suppose the client sends the fin message and the server also wants to close the connection, so server will send the acknowledgement plus fin bit, so both will be combined. Okay, so in this means that both server and so both will be combined. Okay, but if the server wants to send the data, then server will only send the acknowledgement, and the server will only send the acknowledgement. Okay, so similarly, so you can see that this is the procedure used for the connection closure. Okay, so similarly, we take the example that suppose the client want to send data, client wants to close the connection. So it can be also that the server wants first to close the connection. So suppose this message is not sent and the server wants to send to close the connection first, so the server will send this message. Okay, so the connection close, it can be either initiated by the client or it can be initiated by server. Here we took the example that it is initiated by client, but it can be initiated by the server. The server can first choose to close the connection. Okay, so you can see that the connection close, so it means that client and server each close their side of connection when their data is finished. So how it is closed? So they send the TCP segment with the fin bit, and when the client or server it receives the fin packet, then there is this respond with the acknowledgement. Okay, on receiving the fin, the acknowledgement can be also combined with its own fin. Suppose that here the server it receives the fin message. Okay, so server is only sending acknowledgement, but if the server also want to close the connection, then the fin of the server it can be combined with the acknowledgement. Okay, so this message it can be combined with the acknowledgement. Okay, this message it can be combined with the acknowledgement. So okay, so if here the server also wants to close connection, then the acknowledgement will be sent for this message, and this fin message it will be combined with this one. Okay, and also the simultaneous fin exchange can be handled. Okay, suppose that the server and client they at same time they send to each other fin message. Okay, they can send at same time fin message to each other. Okay, so now we have discussed the connection closure procedure. Okay, so now we are going to discuss some more fields of the TCP header data used. Suppose that, as you know that these are the when the TCP sender it receives the data from application layer, so they are divided into bytes and they are stored in the slots, and they are assigned the sequence number. These are the bytes that are sent and acknowledged. These are the bytes that are sent and not acknowledged. Okay, so suppose that, and these are the bytes that can be sent next. Suppose the receiver has 2 bytes, so the receiver can send, so receiver cannot send suppose this TCP it receives 2 bytes from the application, so these 2 bytes cannot be sent in a message. Why? Because it is waiting that the message size should be of a reasonable size. For example, a public transport it cannot start moving with just one passenger in the car. Okay, it waits this a reasonable passenger, a reasonable number of passengers are present in the car. Okay, so similarly here the TCP it waits that the packets should contain a reasonable number of bytes. Okay, so that's why it is waiting. But if it receives a push flake, it means that if these 2 bytes they are urgent. Okay, so if these 2 bytes thereof if the packet size is becoming a reasonable or not, whatever data is present here it should be immediately sent. Okay, so when the receiver receives the data with the P, it is called push flag. When this flag is on, okay, and the data is received by the receiver, so this is urgent. Okay, and you can know that when the data is received by the TCP, so the TCP store it in the receiver buffer. okay, and then the application read it. But if the receiver receives the data with the push flag on, so it is urgent, so it is immediately delivered to the application layer by the receiver. So P flag is used for urgent data. Okay, similarly there are another fields that is called U flag and urgent data pointer. U flag, if it is it, it's also indicating that it is urgent data. But how, for example, this contains the data with the sequence number 50 up to with the sequence number 100. Okay, so it contains the data with the sequence number 50 up to sequence number 100. So it contains 50 byte of data. Okay, so when this data is received, so the receivers keep the data in the receive buffer, and then then it is delivered to application. But if the U flag is on, so it means that this contains urgent data. And up to how much urgent data? For example, this contains the data from 50 with bytes with the sequence number 50 up to 100. So it is, suppose the urgent data pointer is 80. So from 50 sequence number up to 80 sequence number, these bytes are urgent. So up to 80 sequence number, these bytes are urgent, so they should be immediately delivered to the application. Okay, so this U and urgent data pointer is used for this purpose. Okay, but they are normally or generally not used. Okay, now we are going to discuss another flag, okay, that is called R flag. Okay, how it works, it is very important. Suppose this is a machine, okay, and suppose it wants to establish connection or it want to send a data packet, okay, whatsoever. Though I have given it as a server IP address, but this is any machine, it is a client. Suppose it is a client and this is the server. Okay, suppose this is the client, it is not the server, it is the client, and this is the server. Okay, so this wants to establish connection, the TCP connection. Okay, suppose this wants to establish connection. So suppose the TCP it is sending a message with the source IP address. Source IP address is the IP of the server. Okay, this is not server, but this is the client. Okay, and port number is 80. Suppose this is the port number 80 of this application that is sending the message, and the destination IP address, it is the host IP address, this is the server, and the port number is suppose 9157, and this is the port number of host A. Okay, so this client, it is sending the data to this server. Suppose this is client and this is server. Okay, so it is sending this message. So this message is coming from the source IP address this, and from port number 80 of this machine, and this message is going to the destination IP address A and port number 9157. Okay, so when this message is arrived, it is processed through physical layer, link layer, network layer. So in the network layer, the IP address is matching with the A, so it will be processed to transport layer. So in the transport layer, it is specified TCP, so it will be given to the TCP at the transport layer. Okay, now the TCP, it will deliver it to application. So how the TCP identify the application? So by using the destination port number. So the destination port number is 9157, and here suppose this 9157, it is closed, it is closed. Here the port number 57 is running, so the port number 9157 is closed, so the data cannot be delivered to the port 9157 because 9157 is not available. The TCP port number 9157 is not available, so this packet will be discarded. This packet will be discarded. So when it is discarded, then in the TCP we have a feature that this TCP, it will send a message, a TCP message to the source, to the sending machine, and this will be the segment structure. In this TCP message, R flag will be set. This is called reset flag. So this R flag, it will be sent by this application to this application, to this machine. Okay, so when this R flag is sent, so this R flag indicates to this sending machine that when you send this message, it was not, it was dropped at the this machine. Why? Because the destination port number 9157 was not available, it was closed. So this R flag indicates this failure case, okay. So R flag is used, why? Because when a TCP message is received at a machine and the TCP destination port is not running, the TCP destination port specified in the message, it is not running on the machine, then the packet will be discarded because the port is not available, the destination port is not available, so it will be discarded. However, it is discarded, but this machine, it will sense R flag, reset flag. So this it will be sent to whom? It will be sent to the sender. It will be sent to the sender. So it indicates to the sender that this message is dropped. And why it is dropped? Because the destination port is not available. So that's why it is used in the port scanning. Okay, so suppose this machine wants that how many TCP ports are open. So this machine will sense the TCP message for each port. For example, for port number 9157, for port number 9158, for port number 9159. So if the message is sent for 9157 and the sender receives the R flag from the receiver, then it means that this port is closed. If it receives the acknowledgement, then it means that the port is open. So it is used for that, to identify that which port, TCP port number, are open on the machine. Okay, so this can be used, the R flag can be used. So if the R flag is received for a packet, then mean that that port number is closed. And if for a packet the R flag is not received, the acknowledgement is received, so it means that port is open. Okay, so basically this is used in the network security. Why in network security? First, you have, if you want to access to an internet or to a system, so you have to access to enter through a port number, through an application. So if that port number is closed, then you cannot enter. Like for example, if you want to attack an university, so you have to enter to the university through a gate. So this port is working as a gate. Okay, so this R flag is used. Okay, now up to now we have discussed source port number, destination port number, sequence number, acknowledgement number, receive window, urgent data pointer, checksum, and we have discussed urgent data pointer, urgent flag, acknowledgement flag, push flag, R flag, send flag, and F flag. Okay, so now we are discussing header length. The header length, it specified the header length. Why? Because you can see that there is no header length in the UDP. Why? Because UDP has two header lines, first header line and second, and they are fixed. In each UDP, these four header lines should be present. But in the TCP, the first five header lines, header line number 1, 2, 3, 4, 5, they are mandatory. They should be present in each and every TCP message. But there are some header lines that are optional, that are variable, so they may be present or may not be present. So that's why, due to these optional header lines, the header length is included, and it is size of header in words. In words, it is in 32 bit. So if the header length is, for example, you can see the minimum header length is 1, 2, 3, 4, 5, and this one header line is one word. So this, if only these 5 header lines are present, then header length will be 5. 5 means it is, the header length is 5 word. Okay, so if it is 6, it means that it contains one header line optional, one header line, because 5 header lines are must, they are mandatory, and the 6th one is optional. So the 6th one option is included. Okay, so we have discussed the TCP segment structure. Okay, so next we will discuss the principle of congestion control. Okay.